for joining us on NAERLS Smart Farmer Corner on the NAERLS Farming Smart Channel. Understand the soil, feed the soil, sustain the harvest, and secure the future. Welcome back to NAERLS Smart Farmers Corner, brought to you by the NAERLS S3A RG under the FARA, AFAS, SAA C4C Soil Health Series in partnership with Zaria Fertilizer, your partner in productive farming. My name is Halima Musa. Last week, after our discussion on land preparation, soil fertility and input sourcing (ISFM), we took the soil sample from Danladi's farm for soil testing, and the results came back with a soil pH of 4.8. As promised last week, today we will be discussing on the topic the invisible ruler, understanding soil pH and why it governs your harvest. To discuss this topic with me is our soil doctor, Professor C.K. Daudu, Danladi, our medium resource endowed farmer, and Hajia Ramatu, our low resource endowed farmer, and finally Aisha, our soil detector. You are all welcome back.
Thank you.
Before today, I honestly thought pH was just something scientists discussed in the laboratory. You talked about pH 4.8 as being strongly acidic. How does this affect soil health and yield?
Think of pH as a report card for your soil. A pH of 6.5 to 7.3 is considered healthy and neutral. Most crops are comfortable there. Danladi's soil is not there, hence his soil is sitting in the danger zone.
Danger zone?
Yes, imagine you are driving from Zaria to Kano. You see a sign saying bridge damaged ahead. Will you continue at full speed?
Certainly not.
Exactly. A pH of 4.8 is the soil's way of putting up a warning sign. It says, stop, fertilizer alone cannot solve this problem.
Prof, I need you to explain something. If my soil has been at 4.8 all this time, what exactly has it been doing to my crops?
4 major things, Danladi. Let's count them one by one.
Farmers listening, grab your notebook. This may explain years of poor harvest. Danladi, before the soil test came back, what did you honestly think was causing your poor harvest?
Honestly, Halima, I blamed almost everything except the soil. One year, I blamed fake fertilizer. Another year, I blamed poor rainfall. Sometimes, I even thought I had bought bad seed.
So, soil pH never crossed your mind?
Never. I thought if I kept adding more fertilizer every season, eventually the harvest will improve.
Danladi's experience is very common. Many farmers spend years treating the symptoms instead of the cause. Yellow leaves, poor roots, and low yields are often signs of a deeper soil problem.
So today's program is not just about one farmer's soil. It will explain what is happening on thousands of farms across northern Nigeria.
Exactly. That is why we call pH the invisible ruler. It silently controls what happens beneath the soil surface long before farmers notice problems above the ground. So number 1, on the major 4 things, it has been locking up phosphorus. Phosphorus is the nutrient responsible for root development and grain formation. The nutrients may be present, the fertilizer may contain it, but at pH 4.8, the soil locks much of it away. The roots cannot access it. It is like storing food inside a locked room while your children are hungry outside.
So my maize was hungry while food was already in the soil?
Exactly.
Prof, I've seen farmers apply fertilizer twice because they feel the first application was not enough.
Yes, and sometimes the problem is not the amount of fertilizer you apply. The soil acidity is preventing the crop from using it.
That means 2 neighboring farmers can buy the same fertilizer, plant the same variety, and receive completely different harvests.
Exactly so, Halima. One farmer may have a soil pH of 6.3 where nutrients are available. Another may have a pH of 4.8 where many nutrients become unavailable. The fertilizer is the same, but the soil behaves differently.
So I was feeding the soil, but the soil could not feed the crop.
That is a good way of putting it. Number 2, it has been weakening root growth. Weak roots mean poor nutrient uptake, poor water uptake, poor drought tolerance, and poor yields. 3, it has been reducing your soil life. Earthworms prefer healthy soil conditions. Beneficial microorganisms that decompose residues and release nutrients become less active in strongly acidic soils. Without them, the soil becomes biologically tired. 4, it has been reducing your fertilizer efficiency. Every bag of fertilizer you bought had to fight against soil acidity first, and soil acidity kept winning.
Kai, so the fertilizer was not the problem, the soil was blocking the fertilizer.
Exactly, and many farmers listening may be facing the same hidden problem.
Prof, does soil acidity affect all crops equally?
No, different crops tolerate acidity differently. Let's use crops familiar to our listeners as example. Maize performs best between pH 5.8 and 7.0. Below 5.8, maize begins to suffer. Cowpea prefers 6.0 to 7.5. Below 5.5, the bacteria that helps cowpea fix nitrogen becomes less effective. Groundnut also struggles because it needs calcium for proper pod formation. Rice is more tolerant. It can still perform reasonably well between pH 5.0 and 6.5. Sorghum and millet are tougher than maize and can tolerate slightly more acidity.
So two farmers can have the same pH problem but see different depending on their crops?
Yes, that is why soil testing should guide crop and fertilizer decisions.
Prof, does this mean crop choice should also depend on soil test results?
Certainly, soil testing is not only about deciding how much fertilizer to use. It also helps farmers decide which crops are likely to perform better under existing soil conditions.
Now, the question every farmer is asking, how do we fix acidic soil?
Fortunately, acidity can be corrected. The most common solution is lime. Agricultural lime contains calcium carbonate. Its job is to neutralize excess acidity. Think of it as medicine for sour soil.
How much would a farmer need?
It depends on the pH. For soils around pH level 5.0 to 5.4, sandy soils may require about 500 to 750 kilograms per hectare. For soils like Danladis at 4.8 pH, the requirement may increase to around 750 to 1000 kilograms per hectare. Heavier clay soils often need even more. That is why testing is important.
Prof, if I apply lime today, should I plant immediately?
Very good question, Danladi. Lime needs time to react with the soil. Ideally, it should be incorporated during land preparation before planting.
So should farmers correct acidity before the rains becomes established?
Yes.
So Prof, where can I find agricultural lime, or is there any alternative?
Excellent question, Ramatu. Many low resource farmers already have an alternative, which is wood ash, toka.
The same from our cooking kitchen?
Yes, that same ash. Wood ash contains calcium and other alkaline materials. When properly applied and incorporated into the soil, it can help reduce acidity. You can use 1000 to 1500 kilogram per hectare for soil pH of 5.0 to 5.4, or 1500 to 2000 kilogram per hectare for soil pH of 4.5 to 4.9. Instead of throwing ash away throughout the dry season, collect it, store it, use it during your land preparation.
Kai, and so many women sweep wood ash out every morning, Fa.
Yes, that ash can become a valuable soil amendment when used correctly.
So something treated as household waste can improve soil health. Wow.
Yes, provided it comes from clean, untreated wood and is applied in moderation. A farmer's waste can become a farmer's solution.
Prof, if farmers will remember one sentence from today's program, what should it be?
This one: if your soil pH is below 5.5, correct the acidity first, then fertilize. Let me repeat it. Correct the acidity first, then fertilize. Applying phosphorus fertilizer to strongly acidic soil is like pouring water into a sealed container. The nutrient becomes locked up, your money stays in the soil while your crop remains hungry.
Prof, you've convinced us that pH controls fertilizer efficiency, nutrient availability, earthworm, and even heartburn. But how does a farmer actually know whether his soil is 4.8, 5.5, or 6.5? Can farmers see pH with their eyes?
No, farmers cannot see pH with their eyes, and that's exactly why soil acidity is dangerous. You can see weeds, you can see yellow leaves, you can see stunted maize,
yes,
but you cannot see pH. To know your pH, you must test your soil. Fortunately, farmers have different options depending on their resources.
Okay, let's start with Hajar Ramatu and our low resource endowed farmer. What can they do?
For low resource endowed farmers, the first step is a simple pH test. Many extension officers, farmer cooperatives, and development projects have pH strips or simple color kits. The process is straightforward. Take 2 teaspoons of soil, You put it in a clean cup. You add water until it becomes muddy. You add about 2 parts water to 1 part soil. Stir thoroughly and allow it to settle for about 2 minutes.
Okay.
Then insert your pH strip or add the indicator solution. The color changes. Compare the color with the chart on the pH strip. The chart tells you whether your soil is acidic, neutral, or alkaline.
So then, I don't need a lab?
Not necessarily. For a first assessment, a simple field kit can give a useful indication. It is affordable and quick.
How much land should a sample represent?
Excellent question. Do not collect soil from only one spot. Walk across the field in a zigzag pattern. Take small samples from 10 to 15 locations. Mix them together in a bucket. That mixed sample now represents your whole field. Otherwise, one unusual spot can mislead you.
So even with limited resources, I can still know if my soil is acidic or not.
Exactly. Knowledge is cheaper than fertilizer.
How about farmers like Danladi?
For medium resource endowed farmers, I recommend purchasing a simple handheld pH meter or using extension service testing. The meter is inserted into the soil mixture and gives a numerical reading. The pH meter has a range of 1 to 14, and instead of just acidic or neutral, it may even show pH values like 5.2, 5.8 or 6.4 depending on your soil level. That level of accuracy helps farmers make better decisions about fertilizer and liming.
If I had known my soil was 4.8 6 years ago, I could have corrected the problem much earlier.
Yes, and one pH test can save several seasons of wasted fertilizer.
Now let's talk to our high resource endowed farmers, the commercial farmers with larger operations.
For high resource endowed farmers, field kits are useful, but lab testing should become routine. A lab test does much than measure pH. It tells you your soil pH, organic matter levels, nitrogen status, available phosphorus, potassium levels, even your micronutrient deficiencies and lime requirements. In other words, it tells you exactly what your soil needs and what it does not need.
So instead of just guessing, I think they can invest based on evidence.
Absolutely. Many farmers spend hundreds of thousands of nairas on fertilizer while never spending a fraction of that amount on soil testing. That is like buying medicine without knowing the illness.
Suppose I am a farmer collecting samples for the first time. What mistake might I make?
Taking soil sample from one spot, for example, sampling near termite mounds, sampling immediately after fertilizer application, or using dirty containers.
Prof, let's assume we just tested 3 fields. Field A is pH 4.8, field B is pH 5.8, and field C is pH 6.8. What will you tell those farmers?
For field A with pH of 4.8, very strongly acidic.
Okay.
Currently, correct acidity first using lime or wood ash before investing heavily in phosphorus fertilizers. For field B with a pH of 5.8 is good for maize, sorghum, and groundnut. Maintain organic matter and monitor regularly. For field C with a pH of 6.8, which is excellent, most nutrients are available. Protect that soil and avoid unnecessary practices that increase soil acidity.
So number 1 can completely change a farmer's management decision.
Absolutely. That single number may determine whether fertilizer becomes yield or waste.
Prof, not every farmer can immediately afford laboratory testing and extension agents. An extension agent cannot visit every farm in northern Nigeria every day. Is there any way, farmers can get information about their soil before spending money on input?
Yes, this is where technology is beginning to help farmers. Under the C4C project, we now have a digital soil interactive map. Think of it as a soil health atlas. Instead of guessing what may be happening beneath your farm, the map provides information about soils in your areas.
You mean I can look at a map and know something about my soil?
Yes, you can. The map can show information such as your soil pH status, your organic matter level, nitrogen, potassium, and phosphorus status, and even give soil management recommendations.
Some farmers may ask, can a map replace visiting my farm?
No, the map guides decisions, but farmers should still observe what happens on their fields, test their soil where possible, and consult extension agents.
So the map is like a compass. It points us to the right direction.
Precisely, Ramatu. It does not replace field testing completely, but it gives farmers and extension agents a very good starting point.
So you are saying if Danladi had checked the map earlier, he might have known that acidic soil were common in his area.
Of course, instead of spending 6 years guessing, he would have started asking the right questions much earlier. The map covers Kaduna and Kano states for now.
So what about farmers who don't have smartphones?
This is where extension agents become important. An extension agent can assess the map and help farmers interpret the information. Farmer groups and cooperatives can also use the information when planning fertilizer purchases.
Youths can also help their parents, assess the digital map with their smartphones. So the process is becoming clearer. First, observe your field. Second, test your soil if possible. Third, check available soil information such as digital soil interactive map. Then decide what inputs are needed.
Exactly. Remember our ISFM sequence?
Yes.
Diagnose first, build organic matter, apply the right fertilizer, monitor pH. The digital soil map helps with that first step, your diagnosis. In a nutshell, what you need to do is diagnose the soil, observe the field, test the soil, check the digital soil interactive map, and consult your extension agents.
Can we all say this together?
Diagnose the soil, observe the field, test the soil, check the digital soil interactive map, consult extension agents.
Danladi, after today's discussion, what is the biggest lesson you've learned?
I used to think fertilizer alone determined harvest. Today, I understand that soil pH decides whether fertilizer can work.
Ramatu?
I learned that even simple practice like testing soil or using wood ash wisely can make all the difference you need.
And I hope every farmer remembers that diagnosis comes before treatment.
Just as the doctor tests a patient before prescribing medicine, a farmer should also understand the soil before investing in inputs. Before we end the program, Aisha, our soil detective, sent us this week's challenge by phone earlier.
This week's Soil Detective Challenge. Find out your soil pH using any available method. If you have access to an extension agent, ask them to help you use the digital soil interactive map and identify the soil condition in your area. Then compare what the map says with what you have observed in your field. Is your soil acidic? Does it contain earthworms? Does it hold water properly? Drop your responses in the comments section. See you next week.
Thank you, Aisha. Next week, we will discuss selected responses. And don't forget to send your responses to the comment section. Now, let's see our slogan. Say it loud enough for your neighbor to hear.
Understand the soil, feed the soil, sustain the harvest, and secure the future.
And this brings us to the end of our program for today. Brought to you by the Zaria Fertilizers, your partner in productive farming, in collaboration with NAERLS S3A SRG under the C4C Soil Health Series. For Zaria Fertilizer inquiry, call 080-3715-4428. Join us again next week for another very interesting topic. Nomada Hikima, Girbi the Yelwa. Farm with wisdom, harvest with abundance. Don't forget to comment, like, and subscribe to the NAERLS Farming Smart channel. Same Marco Mizua. Until next week, it's goodbye for now.